Hi everyone, my name is Anvita Bansal and we are back with another lecture based on bit manipulation. So let's see the problem for today from our SD sheet. Before that, let me just have a quick check if you guys are able to see me. It hasn't yet started. Let me check. I think we are live. Okay. Fine then. Moving on to the problem for today. So I'll just pause it so that you guys don't have any audio issues. Okay, so we are going to discuss this longest consecutive one. So let's see what is the problem statement. So it is again a very simple problem. You are given an integer n, okay, and you have to tell that how many consecutive ones, what is the length of longest consecutive ones in its binary representation. So for example, you have 14 can be represented in binary as this, right? 1110. So what is the length of consecutive ones that you can see in this representation? It's 3 times, right? So you have to return length as 3. Talking about 222, 222. So this is its binary representation. Now let's take this example and I'll explain you how can we solve this problem using bit magic. So let's take this. Okay, so this is the problem statement that you are, for example, this is the test case, okay, and let me fine. So this is the binary representation for n equal to 222. Fine. Okay, now if I check this number, how many consecutive ones does it contain? So this number is like this: 110 1111 4 times 10. So if I see, I can easily observe that I have 2 ones here, which I am representing with green, and this I'll represent with blue, and 4 ones here. So basically I have 2 set of consecutive ones. Here I have only 2 ones and here I have 4 ones. So what will I return? I have to return the longest length of longest consecutive ones, right? So clearly my answer should be 4. How can I solve this problem? In order to solve this problem, what can we do is, see, this is your given n. Okay, if I do a left shift on n, left shift by 1 on n, okay, so n will look like what? Let's have a look. So this is how your n is going to look like if I do a left shift on n by 1 position. So your n is going to look like this. When we do a left shift, the most significant bit will be removed from your binary and each bit will be shifted to the left position by 1 index and a 0 will appear in the least significant bit. Okay, so let me write it like this. You will get 1, this 1 will be removed and rest of the bits as they are. So I am indicating zeros by red. These are 4 ones which will be remain as they are, 1 1 1 1, and then subsequent bits will be 0, right? Okay, so this is the final number that I have when I do a left on n. Okay, now what? Now do a bitwise AND on n and n left shifted by 1. So when I do a bitwise AND on both these numbers, so what is the resultant I'm going to get? Wherever there is 1, wherever there are 2 ones, you're going to get a 1 there, rest will be 0. So in this process, you know what is happening? I am getting rid of 1 from each set of consecutive ones. How? Let's have a look. So let me write the resultant first. This is going to be 0. So this is going to be 0. These are going to be ones, which I will write by blue. 1 1 1. This is going to be 0 again. Okay, this is going to be 0 again, and this is going to be 1, which I'll represent by green. So if you closely observe, you will see that initially I had a set of ones having length 2 and a set of ones having length 4. Now each set has been reduced by length of 1. So you will see single one has been removed from this set, and also one bit has been removed from this set. So both the lengths have decreased by 1. Okay. Now repeat the same process. So you will do, now your n is this, do a left shift on this n, and what is the number you're going to get? So you'll remove the first one. Okay, you're going to get 0, then another 0. Okay, 3 ones as they are present. Let me write this whole number by red only. 1, 1, 1, and rest numbers will be 0, right? Okay. Now this was your n. This was your n left shifted by 1. This is your new n. This is your new n left shifted by 1. Now you do a resultant doing AND. So what is the number that you are going to get? So 1, 0, 0, 0, 0. These 1, 1, it is going to be 1. I'll represent by blue because it belongs to that blue set. Then it is 1 again. Rest again will be 0. So what did you observe in this iteration? So you can clearly observe that the set which had only 1, 1 does not contain any 1 at all. So again its length has been reduced by 1, which becomes 0. Okay, so I am talking about set of consecutive ones. And if I talk about this set of consecutive ones, earlier it had 3 ones, now it is left with 2 ones only. Repeat the process again. Now this is your new n. Do a left shift on n. So what is your resultant n going to be? So each bit will be left shifted by 1. You remove this 0. You will be left with 0, 0, 1, 1, 1, 1, and rest all will be zeros. Okay. Do a bitwise AND on these two numbers now. So the resultant will be 0, 0. This 0, 1 will be 0. This 1 will give you 1. This will be 0, and rest all will be 0 again. Okay. So 0, 0, 0, 0. Fine. Now what? Repeat the process. This is your new n. Do a left shift on n again. When you do a left shift on n again, you are going to get a number like this, which is 0, 0, 1, and rest all zeros. Now I am repeating the process, which is doing a bitwise AND of these two numbers. So finally what I am going to get is 0, 0, 0, 1, 0, 0, 0, 0, 0, 0. This is where you need to know that you are going to stop any further iterations here. Stop here. So first of all, let's say I am using a loop. Okay, I am running that loop until I get n equal to 0, and within the loop I am continuously doing n bitwise AND with n left shifted by 1. This is your new n, and I am repeating this process until n becomes 0. But how are we keeping the track of length of longest consecutive ones? So do you see one thing? While you are repeating the process, each set of ones length is minimizing by 1 in every iteration. So the set of 1 with the maximum length will be left with its length until n becomes 0. So the number of times or the number of steps that n is taking to become 0 indicates that whichever set of consecutive ones you have, that is the maximum length you can get. That is the equal to the number of iterations that you are doing until your n becomes 0. Why? Because in each iteration, set of consecutive ones is getting reduced by 1 every time. Here it was 2, then it became 1. Here it was 4, it became 3. In next iteration, this 1 vanished and its length became 0. If you just count the length, not that you have to write that length, but count it, you seeing the number of blue ones and number of green ones. Okay, this is for the sake of representation I'm saying so. Now you are left with 3 blues. Okay, in the next iteration 0 green and 2 blues. In next iteration 0 green, because 0 will not go to negative, right? And when you had 2 ones left, now you are left with 1 1, and finally you are left with no 1. So this indicates that this was the maximum length of consecutive ones, because when you got n equal to 0, that means there must be no ones left. And in each iteration we can easily observe that doing this operation n and n left shift by 1, when we are converting our n to this okay, by doing this operation, then we can see how ones are getting impacted, and you can keep a count of length of longest consecutive ones. So what is the length of longest consecutive ones? 4. And how many steps it took you to get n equal to 0? You'll see. First step, I'll just write it here. So when you did n and n left shift by 1, this and I am considering as first step number 1. Okay, then you repeated the process and you did this and, so this is your step number 2. Repeated the process, third and step number 3. Repeated the process, same thing, you got this number equal to 0. This is your 4th iteration. So it took you 4 iterations, which is equal to the length of longest consecutive ones. And that is all about this problem. Very, very simple. But to think about it is not that simple. If you since we are towards the end of bit manipulation, so I'm assuming that now you have got some good grasp over this bits and bit magic, right? So let's move to the code and let me check if you guys have any doubts. Okay, so let's move to take a count equal to 0, and I am taking a loop which runs until your n becomes 0. While n is not equal to 0, what are we doing? We are converting n equal to n and doing bitwise and with n left shifted by 1, right? Fine. And you are incrementing the count by 1, and finally you return count. Expected. And we are done with this problem. So that was all about today's question. So if you guys have any doubt, you can write in the chat, else we will wrap it up.
Of AI.
So I think that is all, and then let's wrap it up. Okay, thank you everyone, take care, see you in the next lecture.